right, hello everyone, and welcome to the flashcard video. So this is going to be a video I am referencing so many times. So if you are watching it a couple months from today, which is the end of October, then I'm proud of you for continuing to work through this. So what students have been recognizing is one of the toughest parts of proofs is knowing what options you have for your reasons, so for theorems, definitions, and postulates, and when to use each one. So what I am encouraging students to do is to think of the concepts we've learned so far in a new set of terms. So now I want you thinking about it as when can I use them and what do they do for me? Okay, so when is it appropriate to apply this idea and why would I apply it? Where would that lead me to? So I'm going to give you two examples and then show you a document that I made to help. So let's talk about the definition of perpendicular lines. Okay, so if we look up the definition of perpendicular lines, it says two lines that intersect to form a right angle. Okay, so up till now, if you could just recite that, that was what you needed. But now we want to think of it as, when can I use definition of perpendicular lines? What would I need to have to use it? And a lot of times students say, well, you'd need to have perpendicular lines. I say, okay, well, give me an example. All right, well, if I knew line A was perpendicular to line B, and remember, you can name lines with lowercase italicized letters, so that's what those are, line A and line B. So they're perpendicular. Great. If you know that, what would I get out from that? All right, well, envision this diagram. So envision this is line A, and this is line B. Well, then I would get that one of those angles right there, whichever one I want, is a right angle, okay? So I'm going to call it angle 1. All right, so when can I use the definition of perpendicular lines? Well, when I am told lines are perpendicular. And what does it get for me? Well, it would get me that like angle 1 is right. Now again, I don't know what the diagram is going to look like. It might not be an angle 1, it might be an angle 5, or an angle ABC, whatever. I will get out a right angle, okay? But think back to what we talked about in Standard 5. Every definition is a biconditional. So if I am told that I have a right angle, I can say if I have a right angle, then I have a set of perpendicular lines. So I can also say, if angle 1 is right, then lines A and B are perpendicular. So I can say, if this, then this, and I can also say, if this, then this. So I can reference the definition of perpendicular lines in a proof anytime I'm at a point where I am told I have a set of perpendicular lines, or anytime I'm told I have a right angle. And if I know this, I'll get this, and if I know this, I'll get this, for this reason in a proof. Okay? So what I'm recommending is that you make flashcards where the term, the definition, the postulate, the theorem, something like that, is on side 1, or like one of the sides of your flashcard. And then the if this fact, then this fact is on side 2 of the flashcard. Okay? You can have a diagram, but really you'll think of it in these terms. All right, so let's do another example. So let's do the congruent complements theorem. Okay, so congruent complements theorem. So that's what I would write on the front side of the card. And then I ask myself, when can I use it? Well, the words say if two angles are complementary to the same angle. Great, but what would that actually look like in a proof? All right, well, it would say like angle 1 and angle 2 are complementary. Okay, but I would need a second. I would also need a different angle is complementary to angle 2. So I would also need angle 3 and angle 2 are complementary. So I would need two sets of complementary facts, and they would have to have an angle in common. If I know that, then what does congruent complement say? Well, it says if two angles are complementary to the same angle, then they are congruent. So I would get that angle 1 is congruent to angle 3. Okay? So if I have this fact, then in a proof, I can get this fact, And my reason is the congruent complements theorem. Now this one's not a biconditional. This is just a conditional. So this arrow is only going to go from here to here. Okay, so that's how we have to start thinking about all the ideas we've learned so far. So then it's like, oh, well then everything we've learned so far? Yes. So what I did is I made you a document that lists every theorem, definition, postulate, property that we've learned so far this year. Okay, so this is linked on the website. So there's a lot. So you can see all of these. So it says 27, but it's really 25 because the first two lines are titles. So we've learned 25 theorems, definitions, postulates, and properties. I guess that's not true because some of these are doubles. Anyway, so this is what I recommend being on side 1. Okay, so it's the definition or theorem or postulate or property name. Then what I've done is I've said, when can I use this idea? When can I use the definition of midpoint? Well, I can use it if I'm told I have a midpoint. What does the definition of midpoint do for me? Well, midpoint is a point that breaks a segment into 2 congruent segments. So I would get out that 2 segments are congruent, AB and BC. Okay, so this is spelling everything out for you. I've listed here whether it's a one-directional arrow or a 2-directional arrow. Every definition is a biconditional, so those all have 2 arrows. In the homework you just corrected, we talked about definition of vertical angles and how you can see you have it in the diagram and from there state you have vertical angles. So I just said if it shows in the diagram, then you can state it. If I have it, could I draw a diagram? Yes, but you're never going to be doing that in a proof. So I didn't show that the arrow went the opposite direction. Okay. All right, so here are the ones we just did in Standard 9, congruent complements, congruent supplements, all of that. So now I want you to consider yourself as a learner. Do you do well if you have actual flashcards? I have quite a few students who do better if they can just run through a packet of flashcards. And even nicer, you can then kind of set aside the ones you're good at. Okay, these I know so well, I don't need to look at those anymore. And then your deck of flashcards can just be the ones that are still causing you difficulty. Other people like making a Quizlet or like making it a digital version. Other people like making their own version of something like this. So kind of think about how you learn best and decide how this can be a good resource for you. Okay, but I will tell you, every time people say, oh, I'm really struggling with proofs, I'll say, oh, can I see your flashcards? And really, when you do this work, it pays off. Okay, so I'm happy to talk about this more with you, but I keep wanting to tell you about it and the time has arrived. These are the flashcards, okay? So good luck. You can do this.